Assalamualaikum. We are from Group 10, K Group, Section 41. We are assigned to monitor the quality of tablet production from LajakLaku to analyze LajakKuruih's tablets of D type. So this is our group members, which is as shown. We are a group of 4.
For question A, we require to describe and summarize the sample data of LajakLaku tablets produced in December 2020. Based on the data of the production of LajakKuruih tablets of month December 2020, we can sort the data in numerical method. Using this data form, any mathematical operation can be made. As we can see, there are 200 observations of data in the table. It's quite hard for us to interpret the table. So in order to make easier for us, we sort the data according to the shift each tablet is made, which are morning, evening, and night. From this table, we can see that the quantity for the morning produced is 62, for the evening is 64, and for the night is 74. From the 3 shift table plotted, we can summarize it into another 4 table, which are the sum, mean, standard deviation, and the overall shift for the weight, relative density, and tensile strength. To get better view of the data is sorted in graphical method.
We move to the question B. So, at the question B, the weight of standard tablet produced by manufacturer should be normally distributed with mean 350 mg and standard deviation of 40 mg to pass the requirement of FDA. So, based on the given data, we need to analyze and create a frequency table with suitable range of value or category. So, as we can see from the first table, they have 2 columns. So, the first column is row level, and the second column is count of weight. And from this table, we need to make sure the interval size is same. So as we can see from the second table, the first column is range of weight, which means interval size for all the data is 10. And the second column is count of weight, which is same as the previous table. So after that, we need to calculate the probability by using normal distribution. So as we can see, the second column is the probability for all the data of range of weight. And the observed value, we get it from the count of weight, just copy into the third table. The fourth column is, we need to find the expected value. How to find the expected value? We need to use the formula expected value equal to n times probability. The value of n is 200. Okay, as we can see from the third table, we can see there's a red number. It is because the expected value need to greater than 5. The first row and the last row for expected value is 3.212, which means it's lower than 5. So we need to combine the respective clusters with the neighboring clusters. So we get the result on the fourth table. So as we can see here, the red number is the result from the combination with respective clusters and neighboring clusters. So after that, we need to find the chi-square test by summation of this formula. And after that, at the significant level, at 0.05, we get the chi 0.055 equal to 11.0705. So from the information, we can see that the data is given. So the P is 0, and so the K is 6. And we need to find the K is K minus P and minus 1, which means we got 5. And from the rejection rule, we need to reject H0 if chi-square test is greater than chi 0.055. So the decision, so as we can see, the value of chi-square test is 2.915, which means lower than 11.0705, thus it failed to reject H0. So at the conclusion, we can conclude that at significant level 0.05, the weight of standard tablet produced by manufacturer follow a normal distribution, which mean 350 mg and standard deviation of 40 mg. So that's all from question B. Move to the next question.
For question C, we need to determine whether there is any significant difference between tablet weights from the different shifts. Firstly, I summarize the data from 3 different shifts, which is this table. We can see that morning has 62 counts, evening has 64 counts, and night has 74 counts. From the summary table, I can construct an ANOVA table, or ANOVA also known as analysis of variance. For hypothesis test, under H0, there is no significant difference between the weights of tablets, while H1, there is significant difference between the weights of tablets. Then we have to make a decision rule that we need to reject H0 if F calculated is bigger than F critical. Our F critical value, which is we can obtain from this table, which is 3.0418. Then our F calculated also we can obtain from the ANOVA table, which is 1.4515. Then our decision, since F calculated is smaller than F critical, which is 3.0418, we cannot reject H0. So we need to conclude that at 0.05 level of significance, that there is no significant difference between tablet weights from the different shifts.
So we move on to the fourth question, which is question B. This question needs us to predict the tensile strength, which varies the values of density values at 68%, 74.3%, and 80.1%. So in order to predict the value of tensile strength, we need to do regression analysis. Okay. So from the summary output, we obtain this table, which is regression statistic table. Shows that the value of multiple R that we obtain is 0.84442, which is indicate that it is close to +1, and it is a linear relationship getting stronger in positive direction. For R squared, the value is 0.713045. It is means that about 71.3% of the data fits the regression model. Okay, so we move on to the ANOVA table. You can see that from the ANOVA table, we obtain the value of regression, residual, and the total from the regression and residual. From the hypothesis test of beta, H0 is when beta is equal to 0, and H1 is when beta is not equal to 0. So we do the decision rule if F test is larger than F critical at 0.05, 1, and 198, which we get the value for F critical from the table. The value is 3.8889. So if F test is larger than this value, so we have to reject H0. From the table that we obtain the value of F test, the value that we obtain for F test is 492.0056. So it is obvious that this value is such a large value compared to the 3.889. Hence, we have to reject H0. So the conclusion that we can make from this decision is the linearity significantly exists between tensile strength and relative density at 0.05 level of significance. Then we move on to the third table, which is intercept and relative density. Same as before, we have to do hypothesis tests for beta When for H0 when beta is equal to 0, for H1 is when beta is not equal to 0. So from the table here, we have to do decision rule, same like before. But we do for t-test. Before this we use for f-test, but this time we use for t-test. So what is the difference? So we go through it, the decision rule. For if t-test is larger than t 0.0598, this value we get from statistical table. The value is negative 1.6526. If the value of t-test is larger than this value, negative 1.6526. So we have to reject H0. So the decision that we make from the table, we obtain the value of t-test is 22.1812. So we go to here. T-test is 22.1812. So you can see obviously the value is larger than negative 1.6526. Hence, we have to reject H0. So the conclusion that we can make from this decision is at 0.05 level of significance, there is a positive linearity exists between tensile strength and relative density. From this table also, we obtain the value of intercept and value of relative density. From these two values, we can create an equation for our graph. Then we can use this equation in order to predict the value of tensile strength. Okay, so for the first graph that we obtain, tensile strength versus relative density, from the equation of fitted line regression, y is equal to 0.2326 plus 0.0786x. I move here the equation. So we use this equation to predict the value of tensile strength when 68% of relative density. So we obtain the value of tensile strength is 5.58 megapascal. For 74.3% of relative density, we get value of tensile strength is 6.07 megapascal. Then the last one is for relative density values at 80.1%. The value of tensile strength is 6.53 megapascal. But if we look closer from our observation, the range of the relative density lies between minimum value of 82 until maximum value of 94.4. But we can see here, value that we need to predict is beyond the range that lies for relative density. So due to that, we can't use this prediction because it is invalid. So we move on to the second graph, the graph of residual versus relative density. You can see the pattern, randomly scattered pattern here along x-axis. It indicates that it is a good fit linear model. For the last graph that we obtained, tensile strength versus sample percentile, you can see the shape of the graph is like this. We can conclude that the point scattered close to the straight line here, and we can assume that normality of tensile strength is satisfied.
That is all from our group. I hope all the data from our report is clearly presented. Thank you very much. Assalamualaikum.
Bye.